Vectors, the superheroes of physics. What are vectors? Imagine vectors as superheroes. Just like how superheroes have both strength and direction, think Superman flying north with super speed. Vectors have both magnitude, how much, and direction, which way. Scalars versus vectors. Scalars, these are like couch potatoes. They have only magnitude, think temperature or mass. They just sit there, no direction, no adventure. Vectors, these are your action-packed superheroes. They have both magnitude and direction, think displacement, velocity, force. They are always going somewhere, doing something. Representing vectors. A vector is usually represented by an arrow. The length of the arrow shows the magnitude, and the arrow points in the direction of the vector. Example, imagine you're a superhero flying 10 kilometers east to save the day. This can be shown as an arrow pointing east with a length representing 10 kilometers. Vector addition. Adding vectors is like forming a superhero team. You combine their strengths and directions to get the resultant vector. Tip-to-tail method, place the tail of the second vector at the tip of the first vector. Parallelogram method, place both vectors with the same starting point and complete the parallelogram. The diagonal gives the resultant vector. Example, if you fly 5 kilometers north and then 5 kilometers east, you don't end up 10 kilometers away from your starting point, but rather at the diagonal of a 5 kilometers by 5 kilometers square. Vector components. Just like how a superhero's power can be broken down, flight speed, strength, etc., a vector can be broken into components. If you have a vector v, it can be broken down into the horizontal component, vy, the vertical component. Example, if you fly 10 kilometers at a 45 degrees angle northeast, you can break this into 7.07 kilometers east, horizontal, and 7.07 kilometers north, vertical. Unit vectors. These are the sidekicks of the vector world. They have a magnitude of 1 and point in a specific direction, usually denoted by I, J, and K for the X, Y, and Z axes respectively. Vector operations. Addition/subtraction, like combining or splitting superhero teams. A plus B equals AX plus BX, I plus by, J. Dot product, finding how much one vector is aligned with another. It's like checking if two superheroes are working together or against each other. AB equals AXBX plus I by. Cross product, finding a vector that is perpendicular to both original vectors. It's like creating a new superhero with combined powers but in a new direction. A times B equals IBZAZ by I, AXBZAZBX, J plus, AX by IBX, K. Applications in real life. Vectors aren't just theoretical, they help in real-world scenarios like navigation, engineering, and physics.